Hi, everyone. Um, Today's date is 1/19/2021, as you can see down here in the corner, and it is Tuesday. This is going to go away because of the way I'm writing it on it. But I have this like this because I want to make sure that I can write it out what I'm thinking, right? So today we learned about the real number system, and there are unreal numbers, but everything under this section is a real number. So rational numbers and irrational numbers are real numbers. Okay, and we have 5 categories of numbers. Natural numbers would be our counting numbers. So 1, 2, 3, and on to infinity pretty much. Okay, our whole numbers include the number 0 as well. So 0, 1, 2, 3, 4, maybe. Okay, dot, dot, dot. So the only difference between a natural number and a whole number is 0. So sometimes on Alex, you may not see the natural number like section, but it is there, just something I want you to be aware of. Integers include all whole numbers, all natural numbers, and they also include the negative whole numbers, the other direction. Okay, so if something is negative, it can't be a whole number and it can't be a natural number because it's not negatives don't include there, right? But if I say 0, 0 could be an integer or a whole number, but you would put it in whole numbers just because that's the smallest box it would fit in. And then our last one up here is our rational numbers. So this includes my integers and my whole numbers and my natural numbers, but it also includes fractions, right? So negative 1.5, right, would go in this section. I could have negative a half, that's a fraction. I could have 1/3 on this side, right? And my fractions go into this. So I am expanding on that. An irrational number is a non-repeating and non-terminating decimal. That means if I have a decimal that is terminating like 1.5 versus repeating like 0.33, that would be rational. Versus if I get something like 0.12233, like that's has a pattern, but it's not repeating in our traditional way. Like one number repeating or a specific set of numbers is repeating, or if I know that I have 3 numbers repeating, those are repeating decimals. This is not. Another thing that falls under irrational is the term pi, right? So what I'm going to do is I'm going to give you an example right now if you need to do this. We're going to drag all of these some numbers around where we think they need to be. Okay? So right now, take a second and pause. 0.75, 0.122, 1, 2, 3, 4, 5, 6, 0.333, 2, 8. Sort them where you think they go. Okay, so pausing if you need to pause. And I'm going to start dragging them where they go. Okay, and it's just going to show up. Okay, so that first layer, I've already moved them. 0.75, those are your rational numbers, right? Because they include partial numbers. And these are irrational because they're not repeating in the traditional sense, right? They're not repeating the same pattern. Okay, so try the next couple you can see. 1, 2, 3, and these 2, and I'm going to move them. All right, so you got the new ones. Negative 100 over 2 is an integer because it reduces to negative 50, which is a whole number. So it's an integer because it's negative. If it was a whole number, it could go into whole numbers. Finish the last 4 down here. Take a pause if you need to, and it's gonna pop up. Okay, and we sorted the last 3. So 2, you'll see rational number of actually 4. 0 over 5 is just 0. So that's a whole number, and that's the first box it fits in, right? So natural number is also a whole number, is also an integer, is also rational. So if I know something is all of those things, I have to sort it like that. Okay, and that is your lesson recap for today. Thank you for joining.